Hi, I'm Alex Williams, enterprise writer at TechCrunch here at the Open Compute Summit with Paramesh Gopi of Applied Micro. Very nice to have you here today.
Pleasure.
Now, you guys have been around, right? You
Yeah.
guys have seen a lot. What are you seeing today that you find so fascinating? What is it that you wake up in the morning and think, wow, this world is changing?
So, I joined the company about 3.5 years ago, and it's kind of a startup within a public company is the way we look at ourselves. And amazingly, 3 years ago, there was no open compute. There was notions of openness in terms of software. But to look at the playing field becoming so large and so level relative to the next generation data center, and having this level of, I'll call it, participation across so many hardware vendors, and really changing the landscape for servers and software-defined networking components, it's amazing. You have software has always been kind of the community where you have lots and lots of developers doing stuff, and it's to a large extent has been the key to changing the dynamics in terms of the cloud. The cloud is only there because of open software. I think what's neat is that 3 years ago we had a vision. How do we become the key, call it disrupting influence for open source hardware? Right?
So, because you had to pick your battle.
Absolutely.
So what were the battles that you were looking at?
So, it's interesting. We were at ARM TechCon, and one of the guys who runs, a very senior guy at ARM, recalled 2009 conversation in London in the park. And I sat there and we argued about, we really need to build an ARM 64-bit server on chip. And they said, what? ARM, we know 64-bit, mobile.
Look what happens when you get outside.
There you go. And he says, well, why? And I said, well, think about it. The whole data center is going to change. Today, 10 gig has become kind of lingua franca, right? It's become like gig was 10 years ago. So with 10 gig, and now we're talking 100 gig, big pipes and computers are coming together in a way that they never had before, right? I mean, you care about, latency on how fast you can pull up a picture.
Exactly.
Well, bigger pipes, lots of computers that can connect to lots of other storage and other types of peripherals are going to be the key. So if I look at what's happened, we had to place a bet. We said ARM 64, not just any other ARM core, but a 64-bit server class ARM.
Why?
Because ARM is the architecture that has the lowest power intrinsically because they're mobile phone kind of heritage, right? Smaller.
Becomes a cost issue.
Becomes a cost issue, becomes a TCO, because it's all about how do you change the total cost of ownership for guys like the Facebook and the Amazons and the Googles, right? Their P&L is a function of their electricity costs.
Right.
And they're the fastest growing, that category of cloud is the fastest growing server category. Why? Because look at how many mobile phone users are being activated every minute with data plans, right? So real problem to solve, and we needed to bring and rethink the entire notion of a server. So here we are today. 3 years ago, nobody envisioned a server on a chip. Today we're talking about what is a software-defined appliance on a chip. For instance, you want to build a common piece of silicon that has very high performance cores, lots of big pipes coming in, so computers, big pipes, and a bunch of other hardware components that can take advantage of the software guys' evolution and innovation.
Right.
So I want to have one card that becomes a storage appliance, that becomes a networking appliance, and that becomes a server appliance. So that's hugely disruptive, right? Because that's never happened in the history of this whole space.
Right.
So that's
a convergence on a different kind of a context.
Exactly. So
because like we see like companies like Oracle saying we're going to vertically provide this convergence.
Exactly.
Right?
Exactly.
But you guys are thinking about more of a horizontal convergence.
You nailed it. And the I call it the leveling, because here's the deal. You had the open source community didn't exist. I mean, clouds didn't exist 10 years ago, right? I mean, to me, I wake up every morning, I'm like, my God, the rate at which we are evolving. I mean, I'm so impressed by the Facebook guys, because they're like, hey, we don't care. We're not going to be static and build the same data center every 6 months. We're going to evolve it based on the evolving needs of what our user population asks, right? So think about this. The only way you can keep up with that is to do what you can do, which is software-defined hardware. So the horizontalization, which is computers, networking, big pipes.
Right.
And by the way, guys, throw whatever software you want on top of that and change its personality.
Exactly. That's where like the special sauce comes into play.
Exactly.
And the algorithm is what says, all right, we need some thyme here, we need oregano here,
You got it.
we need a chicken.
Exactly. It's, you know, it's pasta today, which is vegan macrobiotic, versus for another guy, it's basically pasta with steak and a bunch of chicken on it, right? It's all on one hardware platform.
Yeah, I mean, you could
So-
probably use that analogy to compare like Oracle to whatever.
The Amazons of the world.
Right, the Amazons of the world.
And you know, I think the two words that I keep coming up with, flexibility and malleability.
Mm-hmm.
You can't have hardware cycles dictate data center innovation.
Right.
So, you know, you're constrained by silicon processing time.
Right.
You're constrained by, you know, wow, I need so many years to develop something. Well, when you take a bet, you got to make sure that that bet is malleable enough that you can move it forward.
So what did you come up with today? What was it that you presented on the table today?
So, actually, you know, the ARM-based server thing has been talked about for a
Right.
year or two, you know,
Right.
now. I think we've been very quiet, but we've been very diligent, because we've said, when we build an ARM-based server, it's not just a server, it's a server on chip.
Right.
And today we gave the world a preview into what we're thinking about next, which is we already put big pipes on our first generation.
Yeah.
But now we're talking about gigantic pipes, 100 gig and 400 gig
Yeah.
for next generation.
That's amazing.
That's huge,
Yeah.
because today we're shipping that stuff into the telecom and the, you know, the big router guys, right?
Yeah.
So think about it, we're collapsing large pieces of the router infrastructure
Right.
into tiny little server racks, right?
Right.
So a view into that and a view into the
Everything
fact
is
that
shrinking,
exactly.
but everything is getting more powerful.
Powerful
And
and
we're
lower
seeing
power.
More energy and more energy and more energy. And, you know,
Exactly.
You should read Kevin Kelly's book.
I should.
He was co-founder of Wired, and he talks about this whole idea of the technium, which is this idea that all these machines have this incredible processing power.
Yep.
But the combination of all that, that's where we'll start to see some real major shifts.
I mean, you know, if you think about it, right, we were talking to guys who were like the fathers of software-defined networking about 2 years ago, like Andy Bechtolsheim.
Yeah.
And they had the vision to say, wow, we want to have switches to be able to talk to each other.
Right.
And to be able to communicate at a level that can make the user experience at an end device
Right.
be seamless.
Right.
Now that's become part of the whole open source cloud kind of community,
Right,
right?
right.
So lots of computers talking to each other, very low latency,
Right,
to, that,
right,
to,
right,
to your
right,
earlier point.
right.
But more importantly, now we've got to the point where we've got to do all that in a footprint that is tiny,
Exactly.
right?
Right.
So,
right.
so I think, you know, we talked about our 100 gig and I call it fractional terabit I/O coming to bear on really powerful computers, and then the next generation, you know, we've now to take that and put it into FinFET technology, which is the three-dimensional transistor technology
Oh.
that has been so far the mainstay of folks who own fabs like Intel and IBM. And you know, now we've got the fabless industry like
Yeah.
TSMC and the other fab guys saying,
Yeah.
hey, we're going to do FinFET. So this will be the year that ARM meets FinFET, right?
So yeah, we're starting to see more 3D. I was downstairs
Exactly.
in the hackathon talking to a woman, Sarah Seeley. She has a company called GrabCAD, and they do online collaboration of CAD design. And so mechanical engineers can go and look through a library of CAD designs, but then they can also then collaborate, and they have a 3D viewer, and so they can
I
see
see.
everything so they can see it all and be able to then hack it.
Wow.
You know?
Wow, that's
Yeah.
cool.
So it's all coming. It's like it's interesting. It's like you think about, you know, I've thought about it, you know, in terms of like, well, how everything is a node, right?
Exactly.
The data
Yep.
center is a node.
Yep.
It's like your home is a node.
Yep.
Right? Your car is a node. Everything is a node. I think that's what Frank was getting to a little bit today.
Yeah, no,
Yeah.
exactly right, right? I mean, I think that I was just blown away at the numbers that they were talking about in terms of the, you know, the zettabytes of data that are
Right.
being amassed every
Right.
hour, right?
Right.
So in a way, to take your node analogy to the next level, we become nodes.
Right.
And in time
Exactly.
space, we're just
Yep.
producing more and more data,
Yep.
right? So
Yeah. We're just
Neat,
getting
neat.
smaller and smaller and smaller, and you know, our homes are going to get small. I mean, really, the whole universe is getting smaller. And we
It's
can talk
amazing.
about that for a long time. but
Yep. Yep.
I really appreciate you taking some time.
Thanks.
And,
It's
you know,
a
and
pleasure.
talking here.
So
It's a very interesting event, and best of luck to you guys.
Thank you.
Great.
Appreciate
Thank
it. Okay.